In this video, we're looking at how to obtain measures of center from tables and charts. If you need further information about the measures of center or which measure of center is most appropriate for your dataset, please refer to those videos respectively. The mean, median, and mode are three numbers which help define the center of a dataset. In this video, we're looking at calculating them from tally and frequency tables, stem and leaf plots, column graphs, and histograms. A quick reminder that the mean is the sum of all data values divided by the number of values. The median of the ordered data is the middle value for an odd number of values, and the average of the two middle values for an even number of values. The mode is the most common or frequent value. Let's look at the finding mean, median, and mode from this tally and frequency table. The first thing you should notice is that this is a set of categorical data. Therefore, we can only find the mode. The mode in this instance is brown eyes because it's the most frequent, and you can tell that from the frequency column. We know that to calculate the mean, we need to add up all of the values and divide them by the number of values. There's no way of doing this with categorical data. We know that to find the median, we need to order the data first. There's no way to order categorical data. And even if we had ordinal categorical data, we still would not be able to find the median, as the data is not numerical. When the same data values appear a number of times, we often summarize the data into a frequency table. In order to find the measures of center directly from a frequency table, we need to add a couple of columns. The cumulative frequency simply cumulatively adds the frequency. You'll notice in row 2, the frequency from row 2 is added to row 1 frequency. Then the frequency from row 3 is added to the cumulative frequency from row 2, and so on. I've color-coded these, green and yellow. The other column we need to add is a product column. This tells us that the total attendance for each row, and it is obtained by multiplying the frequency column by the attendance number. These are color-coded yellow and red. At the bottom, we add them to find the total attendance from the sample of the day courses. The mode in this instance is 18 students attending a day class because it's the most frequent, being 8 courses during that week. I've circled it here in blue. Next, we calculate the median value. Don't be confused between calculating the median value and finding the median. The median value is where the value falls in the ordered data set. Once we know the median value, which is 14, we use the cumulative frequency to identify the median. The attendance numbers are already in ascending order. You can identify which row the 14th value falls in from the cumulative frequency column. Once you identify which row the 14th value falls in, you can identify what the median is. In our example here, the 14th value falls into the third row, making attendance of 18 the median value, and I've circled it here in green. Finally, we can calculate the mean using the total of the product column and the frequency column. The total of the product column is the total attendance from the entire sample of courses. The total frequency is the number of classes from the sample. Therefore, dividing the total product by the total frequency gives the mean, or 20 students attending a day class. Here we have a stem and leaf plot of the same set of data from our frequency table. Let's see if we can find the mean, median, and mode from this stem and leaf plot. The mode is clearly visible on the stem and leaf plot. You can quite easily see that 18 years old is the most frequent due to the number of 8s in the leaf. The mean is the sum of all the values from the stem and leaf plot divided by the number of values. A common error is to mistakenly leave the stem off when calculating the total. Remember, the stem and leaf make up the whole number together, and the stem must be included. The mean for this data set is 20 students. Before we can find the median, we need to first find the median value. There's 27 values, so if you add up the number of values in the leaf, so we add 1 to that and divide it by 2 to find the median value, and we know it's the 14th. And the 14th value in the median, which is 18 students. So we just count along the values because they're already in an ordered stem and leaf plot until we find the 14th value, which is 18. You can also determine the mean, median, and mode from a column graph. The process is similar to that of a frequency table, but you have to calculate a few more things before you can find them. The mode is easily visible as it has the highest frequency highlighted in the blue column here. In order to determine the median value, we need to add the frequency of each of the column up, the first being 1, the second being 5, the third being 8, and so on, and we get the total frequency of 27. Then we add 1 and divide by 2, and we find that it's the 14th value again because we're using the same data set. If we add again, we accumulate the frequencies from left to right, so we get 1 plus 5 plus 8. That will equal 14 values, which is where our median falls. So we know that the median also falls on 18, and we found this in the previous example too. To calculate the mean, we need to multiply the frequency by the data value. So the frequency number in the column times by the value on the bottom. This would give us the total attendance, and then we divide it by the total frequency, which we previously worked out to be 27. We cannot determine the mean, median, or mode directly from a histogram. That's because no discrete information is provided, only intervals. We say that the largest class interval is the modal class, highlighted in blue here. The median can still be determined by the median value can still be determined by adding up the frequencies, adding 1 and then dividing by 2. This is 10.5th value I've highlighted here. This tells us what class interval the median would fall in, but we're unable to calculate the median. We can approximate a mean by using the midpoint of the class interval. For example, 15 is the midpoint of the first interval as it falls between 10 and 20. We multiply this by the first frequency of 3. Do this for all the columns and then add them together, then divide by the total frequency. This gets an approximate mean of 33 kilometers because we're looking at the length of wire orders in this example. So in summary, in this video we had a look at calculating the mean, median, and mode from a tally and frequency table, from a stem and leaf plot, a column graph, and a histogram. Thank you.